All right, let's dive into four really key principles of object-oriented design. Now, these aren't just, academic rules to memorize. They're a practical toolkit for building software that's flexible, maintainable, and just solid. So let's get right to the core problem they're all designed to solve.
So, has this ever happened to you? You make what feels like a tiny, simple change to one little corner of your application, and then you watch as completely unrelated parts of the system just start breaking, one after another. It's an incredibly common and, let's be honest, super frustrating experience.
This kind of brittleness, it isn't just bad luck. It's almost always a direct symptom of the underlying design. When parts of your code are all tangled up and too tightly connected, one change can create this massive ripple effect, spreading bugs all through the system. But here's the good news. It really doesn't have to be this way. If you follow a few key principles, you can build software that actually embraces change instead of shattering from it.
So here's our game plan for tackling that fragility. We're going to cover four core principles. First, how to isolate the parts that change. Second, coding to contracts. Third, the idea of extending without modifying. And finally, making sure every rule lives in one and only one place. It all adds up to a philosophy of flexibility.
Okay, so this brings up our first big question. We all know requirements are constantly changing, right? The client wants a new feature, a third-party API gets an update, the business logic evolves. So how in the world are you supposed to build something stable on such shaky ground?
And the answer is our very first principle. Look, the goal isn't to prevent change. That's just impossible. The real goal is to see it coming and to build a wall around it. By figuring out the parts of your application that are most likely to be volatile and then encapsulating them, you protect the stable, unchanging parts of your system from all that chaos.
Let's make this real for a second. Imagine you've got a violinist class. Now, the methods for, say, tuning the violin are probably pretty stable, but the playing method? That could change all the time. One day it's classical, the next it's bluegrass. Instead of stuffing the violinist class with a giant messy pile of if statements, we encapsulate the playing style into its own separate playing style class. Now the violinist just delegates to whatever style is plugged in. See? The part that changes is perfectly isolated.
Okay, so we've isolated the changing parts. We put them in their own little boxes. But wait a minute, that creates a new problem, doesn't it? If the individual pieces are designed to be swapped out, how can different parts of the system reliably work together? How do you maintain any kind of stability?
The solution here is actually pretty elegant. You code to a contract, or what we call an interface. This means that instead of your components depending directly on each other's messy internal details, they both depend on a shared, stable abstraction. This interface is basically a promise. It defines what a component can do, but it says nothing about how it does it. This gives you the freedom to swap in any new implementation you want, just as long as it keeps that promise.
And there's a quote that just nails this idea. Think about it. Implementations are temporary. They're fragile. They change with new tech and new requirements. But a really well-designed abstraction, that can last for years. When you program to an interface, you're not just coding for today. You're building a foundation that can adapt without falling apart.
All right, so our interfaces are solid. But what about the code that's already written, tested, and working in production? How do you add new functionality without cracking open that existing code and risking breaking everything that you already trust?
And that, my friends, is where the open-closed principle comes in. It's a simple idea. Our classes should be open for extension, but closed for modification. Just think about that for a second. If you never have to change a class that's already working, you can never introduce a new bug into it.
And this is where the rubber meets the road. By designing classes that we can extend, maybe through inheritance or by plugging in new strategies, we can add brand new features while leaving the original battle-tested code completely untouched. This just massively cuts down the risk of regression bugs and makes our whole system more stable over time.
Okay, on to our final principle. And this one tackles something I think we've all been guilty of at some point. Copying and pasting code. It feels so fast in the moment, right? But what's the real long-term cost when that logic gets scattered all over your project?
The solution is the don't repeat yourself principle, or DRY, as you've probably heard it. It's the very soul of one rule, one place. The idea is that every single piece of logic in your system should have one and only one authoritative home. If you catch yourself writing the same bit of code in more than one place, that's your cue to stop and abstract it.
So let's just play this out for a moment. What's the real damage when you violate the dry principle? Imagine you've copied some business logic into 4 different places in your app. Now, what happens when someone finds a bug in that logic?
Right. It's not one bug anymore, it's 4 bugs. All of a sudden, you're on a scavenger hunt, trying to track down every single copy and fix each one perfectly. And if you miss just one, the bug lives on. This is a total recipe for disaster and the kind of maintenance nightmare that keeps developers up at night. Keeping one rule in one place isn't just about being tidy, it's absolutely essential for a sane code base.
So as we start to pull all this together, it's really important to see that these aren't just 4 random rules you have to memorize. They're all interconnected. They're all part of a single philosophy. A philosophy of building flexible, resilient software that is actually designed from the ground up to evolve.
All right, let's lock in these core ideas one last time. Number 1, find what changes and wrap it up. Number 2, always code to a stable interface, not a concrete class. Number 3, design your classes so you can extend them, not modify them. And number 4, don't repeat yourself. Every rule lives in exactly one place.
So, if this explainer gave you a new way to think about building better software, we'd love your support. Help us spread the word. Like this, share it with another developer, and definitely subscribe for more deep dives into these essential software concepts.
And I want to leave you with one final thought to take back to your own projects. When you look at your current code base, which one of these 4 principles could you apply right now to make the biggest, most positive impact? Thanks for tuning in.